So we're toward the end of the day, people are tired. I don't bring any high schoolers physically to the room, but you're gonna see a lot of high school stuff. I hope it's fun. I worked 11 years for the industry. I wanted to become a professor because I thought I can have an impact on the way we see civil engineering, and that's what I will present here with Tran-SET. This is the outline of my presentation. This is why everything started. When I joined academia, I was very excited about training the new generations about technology. And I got involved in a STEM class where I could teach undergraduates because it's better to start early. And I taught them about shake table and sensors and drones. And it was surprisingly, that's what they wanted to do. I mean, there were civil engineers, but they were like, hey, I want to run a shake table and design new buildings. So I realized that basically it's a little late when you work with undergrads because you cannot train them when they're 20, 21. I was thinking, you know what, I'm gonna make my dream true and work with high schoolers, bring them to the university and teach them about sensors. So they choose to do civil engineering. So these are 3 of them on our summer SMILE lab, interacting with graduate students, two visiting professors from China, mechanical engineering, computer science, electrical engineering. For them, it's natural to think, well, if I'm a civil engineer, I can build and design and program sensors to change the infrastructure. Because I think we can do that transformation as civil engineers. We don't need to consult. Probably I get into trouble. I don't say working with other disciplines is bad, but I think we can actually educate on that as part of civil engineering. That is how we can manage our infrastructure. We need that training. We say that we need to repair, but how are we gonna do that in a smart way? So we need to have that assessment with the smart systems. The high schoolers embrace that. They want to change the world and they want to actually do the sensors and touch the cables and program the sensors. For them it's natural. I think I am scared, or I was scared, or I will be scared, but for them it's a different generation. They jump on it. So I propose that we need to follow, not my idea, this is the American Society of Civil Engineers. They say that the civil engineer of the future, which is actually 2025, which is the present, will be, this is their quote, will be using living databases, sensors, and diagnostic tools to make informed decisions. And I think we need to change to provide that future today. That's what I say. Even undergrad is late. We have to talk about bridges and sensors and programming is our natural tool as civil engineers. So this is the tool. Actually, I brought one of them. So what we do is build sensors, and we say that building sensors is the natural thing that civil engineers do. So, Mr. Chairman, I'm gonna toss it to you. You can open it. Please pass this one. So actually, it's not solder, so don't shake it too much. But basically, this is what I'll be talking about. It's an Arduino. People, actually my generation don't know what an Arduino is, but for high schoolers, they all use it. I mean, it's like algebra, calculus, and Arduino. It's an accelerometer that we attach to the Arduino with 4 cables. An accelerometer is one sensor that the students don't run away when they hear sensor. They actually come inside the room and they want to try and they want to look at accelerometer data. So it's very easy to teach this because they are ready to learn it. And wireless antenna, I didn't bring the sequence here, so you won't see it there. But wireless for them is the natural conversation. They don't get scared about wireless. They actually want wireless. And they will learn wireless because they believe they should do wireless. And this is the cost. So I propose low-cost sensors. I do it also for research. So you can get this low-cost sensor in your research. You can have affordable experiments. So it's not only for the high schoolers. Actually, they don't like to play. They want to believe what they're doing is actually very transformative. So you will lose their attention if you give them something that is not exciting. They have to believe in what they're doing. And we have actually, now we have two, and we're working on the third version, but we create a little, we have SD card, we have a solar panel, we have an enclosure that is actually certified, so we're getting a little overboard, but it's once you start, it's hard to stop. What we did is actually create a summer school for high schoolers for smart sensors, not for PhD students. And they came, we actually was very successful because first we talked to them about American infrastructure, different means of transportation. And then we say, what about if you would like to replace things? And they were, well, I said, well, they want to build a sensor that can inform you on which one you need to prioritize. And we paired them with a mentor. So actually, they want directions about how to do it, but they follow them very, very quickly. And this is a little video, I think it's like 20 seconds, and I have like 4 more videos. So we have one high schooler with one mentor, and in 30 minutes, we give them instructions. In 30 minutes, and we also give them the libraries and the code, which is relatively simple. They download it on their computer, and they can move the sensor and see the real-time data on their laptops. And they feel so powerful doing that. And then this is the ASCE American infrastructure. So we'll relate this infrastructure need with the ability that they just learn to make an active learner and participator. I did a survey, and at the end of the survey, I said, what did you learn today? And they wrote this: connecting wires is like making new friends. So they're building the sensors, and they're building something bigger than I would ever think. They're building an understanding, they're building a team. The mentor was something that I didn't even think before I started. It really, for that half-an-hour interaction with the grad student, we became their friend. Very, very inspiring. And then we took them in Albuquerque. We had a tramway that they can, we added as the field trip. So after they built the sensor in the morning, we took them on the tramway and moved the dynamics. So they could calculate the natural frequency, which is actually 0.2 hertz, like 5 cycles. And they really loved that. They felt like, wow, so now we are measuring the tramway. Some of them actually never took the tramway before, so it was maybe a mix of excitement. And again, they're there with the infrastructure report card, so very powerful. We have a representative from Congresswoman Grisham Lujan. She came and we gave them diplomas at the end. They actually presented, they made a PowerPoint presenting their work. So very, very, very rewarding. I have an explanation for Lewis. So when we're writing the paper, actually we have a highly cited journal. That was when Jerry Lewis passed away. That was like August, I think, in the summer. So that's what we came with, a low-cost, efficient, wireless intelligence sensor, like a tribute for the 90 professors. And the paper, again, this is not only outreach or education, we're also doing other kind of research like reference-free displacement measurements with sensors, which is relatively complicated because you need a reference point. Here with Lewis, we get very good results. So you could actually, for $70, could collect this reference-free displacement on your structure, which is very powerful. I have, how much time I have? Like halfway there?
Yeah, you have still 12 minutes.
Perfect, so I will slow down then. I'm interested in this technology-human interaction. I was talking with Dr. Simmons before. It's a lot that we don't know there. And I think we need to change our approach to technology and bring the human first and see where is the human really moving to, and then we can bring the technology about that human. We can build like a superhuman. The sensors alone don't help humans. You could give a human like a 30 gigabytes, and they put it on their pocket. That doesn't make them better. So why don't you augment what they are actually lacking? So this is Selene. It's another high schooler. She's a senior in high school, and we made a YouTube video about how to build a low-cost sensor, and she loved it because actually she wants to change the access to technology. And actually, she wants to be a doctor. I'm trying to convince her to be an engineer, but she's very designing medical school, but she likes the technology as a tool to change the world. So anyway, she has doing that sensor. And why was she being a doctor? Why did she jump into a sensor? Well, she made a capstone project with me. I said, what do you like? I said, well, I'm a dancer. I said, perfect. I love dancing. So why don't we collect objective information of your dance the way that we add information that you don't have? Like, so for dancing, for example, you would like to know if you are repeating the tempo, or maybe, actually you could do it with two dancers too, right? Instead of looking at them, what if you look at the data that they're generating, and you can compare their data. And actually we're looking into even more crazy concepts like real-time dancing, where you could measure your dance and correct your steps based on the data that you see on real time. And I think we can do it actually. It's not that crazy after all. So what she did, she worked with grad students actually, mechanical and electrical. And she collected 2 dance, actually this is one of 6, so she knows a lot about types of dancing, and she collected the data, and then here as a preliminary analysis, you can see, well, the second one went a little faster. And also you can see the second one had a little higher amplitude from acceleration. If I can play this again, I think now that you know this, you can pay attention and say, well, in reality, it's hard to tell, but you can see actually her heel is coming straight on the floor, or kind of she's moving it a little bit. So what you're doing is to do some machine learning. You're training your data to inform what the dancers are looking for, but you cannot do that if you don't talk to the dancers. If you look at data alone and you say, I'm an expert dancer, analyst, you're fooling yourself. You need to be the dancer first, and then you can do the machine learning for the dancer. And she was very engaged with this, and now she will be presenting actually on MIT on the Engineering Mechanics Institute in May. She's very excited. She did very well on her high school, and I think we are limiting our high schoolers. I think they want to go even farther than we can even think. If you just tell them, well, even more, they jump at it. And she doesn't want to be an engineer. That's very impressive. Augmented reality. So I didn't bring the HoloLens here, but I'm working a lot in this augmenting human abilities. High schoolers love that. We don't like that because we think it's a little too crazy. But the technology is there to actually bring to the human abilities, augment human abilities that, so for example, I'm not very good to count how many chairs are in the room. I shouldn't do that. A machine should do that for me. So I would actually look at the room and know that there are, 150. So it's better to augment properties that humans don't have. We're doing it for crack. We're measuring the crack length, working like time machine cases, teleportation. So here, like the high schoolers love that. So I do a lot of outreach, I think, but I don't think it's enough even. So that we went to museums, went to high school, to the Native American Engineering Open House, the Explorer Museum, and again, it's very easy to talk about becoming an engineer to a 10-year-old when you wear the HoloLens. They go with you whatever. So that's what I've been doing on the outreach part. And this is a high schooler. I did that like when you wear the HoloLens, it kind of, not many people were doing that like a year and a half ago, so we didn't know what to do. So I asked a high schooler to go there and start taking measurements without touching our little bridge on the lab. And he was making like inspections, recording his voice with the HoloLens. And it is that, I could do that myself, but it's kind of interesting when you give duties to others that you don't even plan what they're gonna do. And he was actually collecting the time, and the time that he took the inspection, and the amount of measurements that he did. Actually, you can leave these measurements on the field forever, so you can anchor your inspection and provide that information. So we're doing that in the concept of time machine. And this is another high school, Native American Douglas. It was very cold that day on the patio, but we wanted to have a benchmark of the accuracy of our HoloLens measurement depending on the distance and the angle. And surprisingly, this is for 20 feet away from the 12 inches measurement. It was under 3%. So it was much better than we thought. We were not very worried about the accuracy, but it helped us to provide that no-touch distance measurement of cracks. We are measuring also area, and the next thing we're implementing is the volume, real-time volume failure in your bridge inspection, for example. For the future, so based on the success of the high schoolers, now I'm teaching for the first time in civil engineering, correctly if I'm wrong, I'll be very happy to hear. From my structural dynamics class, if you take my class, you're going to build one of these guys. Actually, you're going to keep them so people kind of get a trade-off there. And then they're going to use it for their homework. They're going to go to the Tran-way, and they're going to calculate the natural frequency of the Tran-way. So that's, that's pushing the envelope because a lot of students actually, surprisingly, they don't want a lot of extra work because they have very important things to do. But I think they like it because I asked them, hey, was it better to say no that? To measure the natural frequency on the Tran-way, I enjoy that. And this is the building of the sensor. But again, this is kind of a revolutionary because civil engineers typically we don't like cables. We don't like coding cables. Maybe you need to move the cable to have the right coding. So. And we have instructions, so it's not like they have to do it alone. But once they are here, they believe they can build the next sensor if they need to. Okay, so I go forward. And the second consequence, I'm teaching for industry because that was the kind of the Tran-SET goal. We need to transform also like the workforce. So I can go to a bunch of engineers now and tell them, hey, my students are doing it. Well, they're graduate students. Hey, high schoolers are doing it. Well, they cannot go away without that, right? So if the high schoolers can do it, this was the first time we done it in the International Model Analysis Conference. We have 14 people, and actually we did the same. But again, it's a kind of transforming the force world. If you want to talk about signal processing, you need to build your own sensor, and you're responsible for the quality of the data that you collect. Finally, with Tran-SET, part of our project was to organize a workshop to learn from industry what are the needs, what is the need from the owners of that technology. And that will be in 2 weeks actually from tomorrow in Fort Worth in the Structural Congress in Fort Worth, Texas. Everybody's invited. We are still taking people. It's free. You just come there and give us your input. You may have contacts there, so please tell them. I can send this to anyone. And it's 3 hours. We have two of my students will come. We have 6 owners of infrastructure coming over from the railroad, so it's very industry informed. In conclusion, I think the future engineers can build and design their own sensors. It's part of their contribution to this management of infrastructure. I show you the little Lewis that we have here. You touch it. Next time, in 20 minutes, maybe I can teach you how to build it. I mentioned a little bit about augmented reality. I didn't show anything about drones, but we're doing we're touching the structure with the drone, actually. I think that's the next step. You go there and scratch your structure and learn from that touching. And I think it'll be part of their degrees. Maybe we are resisting, maybe in 10 years it will be part of the requirement. If we're going to manage infrastructure, we need to actually have the tools. And this is the people who did the work. So it's, I have a lot of interdisciplinary, interested people to work on this. So I can see what engineer I wouldn't do it. So a lot of support, and thank you, Tran-SET, for supporting this research and believing on us. And thank you for being here today.